Hello everyone, welcome to Math Enthusiast channel, and for today's video, we will be solving this integral problem such that a is equal to integral from 0 to 1 of ln x squared plus 1 over x squared plus 1 dx. So, to begin solving this problem, we will do some substitution or trigonometric substitution in particular. So, to simplify this integral, we will let x be equal to tangent theta, and then dx will become tan squared theta plus 1 d theta. So here, notice that since x is equal to tan theta, then we could also say that dx is equal to x squared plus 1 d theta. So here we now have a is equal to since arctan of 1 is equal to pi over 4 and arctan of 0 is 0, then our limits will become from 0 to pi over 4. And here we will be substituting x as tangent theta, and we will get tan squared theta plus 1. And since our dx, since our d theta is dx over x squared plus 1, then it will become just d theta. So now, since we know that tan squared theta plus 1 is just equal to secant squared theta, then this integral will become integral from 0 to pi over 4 of ln secant squared theta d theta. Or we know that secant squared theta is just equal to 1 over cosine squared theta. So here we now have negative 2 of ln cosine theta d theta. So here, by king rule of integration, you know that note that king rule of integration is given by integral from a to b of f of x dx is equal to integral from a to b of f of a plus b minus x dx. So this is the king rule of integration. So by using this formula, then our a is now equal to negative 2 of integral from 0 to pi over 4 times ln cosine of pi over 4 minus theta d theta. And from Pythagorean identities, this would simplify to integral negative 2 times integral from 0 to pi over 4 of ln sine theta plus cosine theta plus ln square root of 2 over 2 d theta. So now we have this, and it is also equal to negative 2 times, we will just transpose this negative 2 to the left hand side, and we will have now negative a over 2. We will just cancel it. So we now have ln of tan theta plus 1 of d theta plus integral from 0 to pi over 4 of ln cosine theta d theta minus, if we integrate this, since this is just a constant, then we will just multiply this by its upper limit. Since our lower limit is just 0, then it will just vanish. So if we integrate this constant term, then our answer will become negative pi ln 2 over 8. So notice from the beginning, this is just equal to negative a over 2. So this is the same as negative a over 2. So now since both sides are having a negative a over 2, we can just cancel those terms, those like terms. So if we cancel those terms from both sides, then we will get the answer for this integral as integral from 0 to pi over 4 of ln tan theta plus 1 d theta is just equal to, if we transpose this to the other side of the equation, this will become positive. So this is equal to pi ln 2 over 8. So now, going back to our original goal here, we have a is equal to 0 to pi over 4 of ln tan squared theta plus 1 d theta. So by multiplying both sides of this, we may get the answer for this. So we will just experiment here to manipulate this integral. So here we will just copy it or rewrite it down as integral from 0 to pi over 4 of, since we multiply both sides by 2, then this will become 2 ln tan theta plus 1 d theta and pi of ln 2 over 4. So now from the natural logarithms rule, we know that 2 ln of tan theta plus 1 is just equal to ln of tan theta plus 1 squared. So if we expand this, then we will get 0 to pi over 4 of ln, we expand this thing, 2 tan theta plus tan squared theta plus 1 d theta is equal to pi ln 2 over 4. So since we know that tan squared theta plus 1 is just equal to secant squared theta, then we we may say that this is just the same as ln sine 2 theta plus 1 d theta minus 0 to pi over 4 of 2 ln cosine theta d theta is just equal to this. So here we know that this is just equal to this, and this is just equal to a, so this term is just a. So we could now say that a is just equal to pi ln 2 over 4 minus, if we transpose this integral to the other side of the equation, this will become negative. So this is minus 0 pi over 4 of ln sine 2 theta plus 1 d theta. So now we will be focusing first to this integral. So if we do some substitution, we will let let's say z is equal to 2 theta, then dz is equal to 2 d theta. So now by substituting this to this integral, then we will have our a is equal to pi ln 2 over 4 minus 1/2 times, since if we plug in the value of of theta here, since 2 times pi over 4 is just equal to pi over 2, then our upper limit will become pi over 2, and for our lower limit it will remain the same, equal to 0. So we now have ln of sine z plus 1 of dz. So note that from Catalan's constant g, given as g, this is equal to the 1/2 times the integral from 0 to pi over 2 of ln sine z plus 1 dz minus 1/2 of integral times from 0 to pi over 2 of ln cosine z dz. So by using this fact, so we can now say that this integral is just equal to g plus this integral 1/2 times integral from 0 to pi over 2 of ln cosine z dz. So now we will be using this integral. Minus g plus 1/2 0 to pi over 2 of ln cosine z dz. So by focusing on this integral, so we will be solving this on separate paper. So now we will consider a sub 1 as equal to 1/2 times integral from 0 to pi over 2 of ln cosine z dz. So by using the king rule of integration, this is the same as 1/2 times integral from 0 to pi over 2 of ln sine z dz. So by adding these two integral, we will get 2a sub 1 is equal to 1/2 times integral from 0 to pi over 2 of ln cosine z plus ln of sine z dz. So we know that from natural logarithm rule that ln of a plus ln of b is just equal to ln of ab, such that ln plus of a plus ln of b is just equal to ln of a times b. So by using this rule of natural logarithms, then this is the same as saying that this is just equal to 1/2 times integral from 0 to pi over 2 of ln sine z times cosine z dz. So from Pythagorean identities, we know that sine of 2z is just equal to 2 times sine z cosine z. By dividing both sides by 2, or simply just saying that these two will be transposed to the other side, and this will become 1/2. So sine 2z is just equal to sine z times cosine z. And by using this identity, then our integral is just equal to 1/2 of integral from 0 to pi over 2 is just equal to ln of sine 2z minus ln of 2 dz. So we will first solve this integral of constant term. So if we integrate this constant term, we are now left with 1/2 times 0 to pi over 2 of integral of ln of sine 2z dz minus pi ln 2 over 4. So by substitution, again, we will let w be equal to 2z and dw is equal to 2 dz, or dw over 2 is dz. So we will substitute 2z as w, and now we are having our 2a sub 1 is equal to 1/2 from 0 to pi, since 2 times pi over 2 is just equal to pi, and ln of sine w and dw over 2 minus pi ln 2 over 4. So we will just factor out this constant 1/2, and we will move out this from our integrand. So this 1/2 times 1/2 will become 1/4. And from integral rules, we know that 1/2 times integral from 0 to pi of f of sine x dx, where f is some function or any function, is just equal to integral from 0 to pi over 2 of f of sine x dx. So by using this formula, we will now have our integral this is just equal to integral from 0 to pi over 2 of ln sine w dw minus pi ln 2 over 4. And from what we have earlier, we know that this is just equal to a sub 1. So this is just equal to a sub 1, and we are now left with 2a sub 1 is equal to a sub 1 minus pi ln 2 over 4. And by transposing this a sub 1 to the other side of our equation, then we have a sub 1 is negative pi ln 2 over 4. So going back to our original question of integral, we will use this a sub 1 negative pi ln 2 over 4, and we will just substitute the value of a sub 1. So this is our a sub 1 equal to negative pi ln 2 over 4. So the final answer will become like this: a is just equal to negative g is Catalan's constant plus l pi times ln of square root of 2. So this is our final answer to the problem. So if you like this video, please consider subscribing my channel, and don't forget to like this video. And thank you. God bless you all.